So ChatGPT, the GPT, the key part is the generative pre-trained transformer, right? And you zeroed in on the transformer part. And for those not familiar with neural network architectures, that's the flavor of the day. I feel like there's this zoo.
Christian, welcome to the show.
Thank you so much. It's great to be here, Sean. Thanks for having me.
Yeah, thanks for being here. I'm really excited for this. We've kind of known each other, I guess, in some capacity for a few years, but this is the first time we're actually ever speaking to each other with our voices face to face rather than essentially sending messages on Twitter. But
exactly.
Correct me if I'm wrong. I believe you first discovered some of my work from reading my blog while you were preparing for the show Survivor.
Yeah, that's correct. So I was preparing for Survivor, and I'd actually been a long time Survivor fan before I was a contestant, and I guess I'm also a robotics researcher. That's, I guess, my day job. Mm-hmm. But yeah, I came across your work because you were working with, I believe, Angie Kantz and Amanda Rabinowitz, Dr. Amanda Rabinowitz, on this system for predicting who would win a season of Survivor based upon data available from an episode and also informed by character traits. I thought that is one of the few predictive systems out there that I thought was very thoughtful. and this is we can go into the weeds on this, I'm sure, for a long time, but it was really interesting. You use, I believe, clustering to cluster together the different personality traits on a reality show to try to predict a winner, and it was really successful until it predicted that I would win. Until then, it was really successful. So I'm sorry to have broken that streak for you.
Yeah, no worries. Yes, I used a combination of like k-means clustering and naive Bayes classifiers, some old school sort of AI techniques, but which in some ways, is very related to what we're going to be doing today. But I, of course, know you from Survivor, and as one nerdy man to another, that's also into the same reality TV. We started, exchanging those messages, looking for potential projects. We kind of talked about a couple times, but we haven't really did anything until now. And as I kind of teased, we're going to be talking about one of the hottest topics in the internet right now, which is ChatGPT. But maybe before we get there, could you, introduce yourself? You touched on a little bit of your background, but for those that aren't in the robotics research world or Survivor super fans, what do you do and how did you get to where you are today? And I guess, why are you qualified to talk about ChatGPT?
So first off, and thank you for having me today. It's good to be here. So my name is Christian Hubicki. I'm a robotics professor at the FAMU FSU College of Engineering. I have my background is in robotics. My dissertation was in robot control and optimization methods to make robots walk and run better. We're talking your classic sci-fi two-legged robots that you've seen in science fiction movies and Elon Musk has been dabbling in recently, that kind of stuff. So I got my degree in mechanical engineering and robotics, my PhD, and now I run my own research lab where we do sort of fast-thinking optimal control for robots, and we've expanded in from bipeds into drones and some hyper agile maneuverable systems. And so we're very interested in how we can get computers to quickly compute a best response to a situation, which takes us to, I guess, analogously so into the ChatGPT world, which is taking in inputs and then trying to come up with the best response that it can. So in terms of my background, so I should say, so my background is in robotics, and I do know some machine learning from my course days, and I teach it in a few graduate level classes. But I'm not a deep learning expert, so this is me learning things from the literature and my general understanding of the field. I feel like I learned machine learning right before the deep learning boom. I think I was precisely ill-timed for the beautiful deep learning boom. I don't know about you, Sean. What was your background in machine learning? When did you learn it?
Yeah, so my master's degree I did in AI and machine learning, but it was mostly on sort of designing models, new types of models for processing textual information. And back then it was very much like, bag of words approach of doing essentially like, distance measurements between feature vectors. It was really also before the deep learning. I did a little bit of neural network stuff, but never at the level that people are doing it today. So I also kind of miss that era. So a lot of my like practical use of AI is probably 20 years, 15 years out of date at this point, but still useful, as
So useful for sure.
yeah, but it's still used in practice as well. But I'm kind of out of the loop on some of the things like reinforcement learning, some of the newer innovations that have happened in the space.
Yeah, and we'll get into the details soon, but yeah, it was, but yeah, a lot of these older techniques. I mean, we're talking like support vector machines and those things for classification. That and we can go into some of the categories of things, but for robotics, they were really in their infancy when I was learning this stuff back in the early 2010s. The reinforcement learning was a thing. I remember when I was a master's student, I found Sutton and Bartow's reinforcement learning textbook, and I got the PDF, I printed it out, and I read it the whole thing over a spring break to just really digest it all. It was great for very simple systems, but as robots became more complicated, it just wasn't ready. So I ended up using optimal control techniques, which tend to scale well to higher, more complex robots with more linkages, more arms and motors and stuff. But these days, deep learning is being more and more impressive for how to handle that complexity. Sort of diving right in here, but that's my background so like when I go to conferences, I'm talking with my colleagues, some of whom are really into deep learning methods for controlling their robots. I'm more on the, let's call it the shallow learning side of the spectrum for what I like to approach it. But that's my familiarity with deep learning and just a general fascination with the cutting edge of AI and explaining it to people who are willing to listen for some reason.
Yeah, I think that's perfect level for what we're going to be talking today. So, just kind of starting to move towards getting into the weeds here. A few weeks ago, I went to lunch with some of my former colleagues from Google. And, once we were done sort of discussing the recent layoffs that had been happening in the industry and in particular at Google at that time, everything inevitably shifted to talking about ChatGPT. And we spent the rest of the time kind of talking about it. And it sounds to me, just based on these conversations with various, former colleagues, Google's pretty concerned about this as from a threat perspective. So first, what was your initial reaction to ChatGPT? And then I guess second, why do you think the internet has kind of lost its, collective mind over it?
This is a wonderful question, and I'll tell you just from my perspective. So I'm a professor, so the conversation around the department a lot of times about ChatGPT is, can it be used to cheat on our assignments?
Yeah,
that's a lot of what it comes down to for us. So yes, it's been the talk of the town over here as well. So when it came out, there was immediately some buzz about it, especially. It brought to light not only its ability to take a prompt and then generate whole paragraphs, whole essays, but computer code. And this is something that is not entirely new. There's the Copilot type features for GitHub. That's not entirely new, but it's my first time where I said, I really should look into this more deeply, see what it can do. And so I sat down with my laboratory. We were having our weekly lab meeting, and I was okay. Let's try it out. And it did at times reasonably well at generating code. And we even kind of challenged it to try some more complicated things, and it, at times would swing and a miss, and sometimes would make up functions that didn't exist. So I sort of had this. I said, okay, you know what? I'm going to take a deep dive. So for me, onto ChatGPT. So I took a whole Saturday, and that was ChatGPT day for me. And I decided, okay, I want to really test this out, and both as a teacher and a researcher. And I kind of went through the whole hype cycle, I felt, over the course of a couple of hours, where initially I was sort of skeptical, what's going on with this? And then I started getting it to do some, write an essay about the Scarlet Letter, like I was a ninth grader who didn't want to do their homework. And it did a decent job. And I started giving it progressively more difficult coding assignments, like it did my tutorial level coding assignment that I'll give the students, bang on, right out of the box. And for me in robotics, that's make a simple robot that's just a swinging pendulum, and then throw a motor on it in the simulation and then control it, which is a pretty simple thing that you give to starting students. And it just nailed it. It really did. And I started giving it progressively harder assignments, and I was like, oh my goodness. Then up to the point where I was like, I've always wanted to code this particular algorithm, but I've never gotten around to it. I'm going to have ChatGPT do it. See what happens. And it started generating code. It was for an interior point quadratic programming solver, in case anyone's curious. It's a helpful tool in robotics for computing control inputs. But that's a detail. And it spat out a bunch of code. And my eyes were wide with delight. Like, oh my goodness, this could change everything. And then I put it into, I copied the code, ran it, error. I'm like, dang it. Okay, error, that stinks. Okay, but however, you can ask ChatGPT to fix the error. There's an error here, can you fix it? And it goes and it tries to fix it, and I realized, oh, it doesn't know how to fix it. And then I realized, oh my goodness, it put together something that looks like should have been this algorithm, but it had like fundamental limitations because it really didn't understand what it was doing. And it kind of dawned on me that that ChatGPT, and I don't know if you have to bleep this, but it's kind of a bullshitter. Okay, that's what it is at heart. It's a very well read or like like a lot of information at its fingertips, but it's feeding you a bunch of BS. And sometimes that BS is amazingly kind of weirdly on point and it can give you working code. But it doesn't really get that what it's putting together might not even be right. And it is blissfully unaware of this fact. And I kind of came down from the height cycle. I realized, oh, this is what it's doing. It's good at stringing together information. And as I started to read more about how transformers work, etc., we'll get into that, and to how ChatGPT works, this all started to make sense, and started to make sense in the context of how I understand how machine learning algorithms work, how they function. So I am now at a point where I'm like, this is an interesting tool. This is interesting. However, I have a lot of reservations about where it's going and how it can currently be used. And you talked about Google, right? And we'll get back to your Google question right now. Right. And so you are a former Google employee, Googler. Is that what they call you?
Yeah.
Is that right?
Yeah.
Googler? Yeah. I mean, and when people were starting to say that this is a Google killer, because you can ask it a question, right? And it just gives you an answer in English or whatever language you want. I thought that was interesting that Google was really threatened by that. It makes sense. However, it's got a way of just BSing answers. And you might say that, yeah, well, Google also just can grab answers from anywhere that could be wrong. It could grab a website that could be like misinformation. However, I will say, if I Google something and it gives me a website of a thing, of an answer, I can check that website. Who made that website? Where does it come from? With ChatGPT, all of the information gets thrown into basically a blender, and it comes out the other side as some answer. So you don't know where it came from. In fact, if you ask it, sometimes it'll just make up an answer where it came from. It's amazing. So anyway, so as we get into more about ChatGPT, that's sort of like my current thoughts. I was like, it's a phenomenal proof of concept. It can do amazing things, but can we count on it to do amazing things? And that's the big question I have.
Yeah. Yeah. I mean, I think similarly, when it first blew up, I was, pretty skeptical because I've seen other hype cycles in AI, especially with chatbots. Like I think it was Alice or something like that from Microsoft years ago. And, there's been a bunch of these systems over the last 15 years. And I'm like, it's just going to be like those. And then when I tried it, I was, also substantially sort of wowed by it at the beginning. But I do think that source attribution is a big challenge. And I know that Microsoft is supposedly working on this, but that is, I think, one of the big barriers to it being used as, something like a potential replacement to Google. Well, getting into how ChatGPT was actually built. So it's built using a large language model, specifically a variant of the transformer architecture. Can you talk a little bit about how these models work and how was ChatGPT in particular trained?
So ChatGPT, the GPT, the key part is the generative pre-trained transformer, right? And you zeroed in on the transformer part. And for those not familiar with neural network architectures, that's the flavor of the day. I feel like there's this zoo of interesting neural network architectures. Before it was like recurrent neural networks at one point, or long-term, short-term memory networks. and it feels like every year or so another cool architecture comes out that fixes a lot of the problems of the previous one. So it's a fast moving field. I remember I was actually at a workshop of a bunch of folks who were working. It was a kind of a general a meeting for a lot of people working on robotics and self-driving cars. And I remember I was talking with someone who was more of a deep learning person. He was like, yeah, transformers, I'm generally skeptical, but transformers are pretty good. And so what do the transformers do? Well, so transformers were introduced in a paper which has a beautifully simple title called "Attention is All You Need" by Google, your alumni organization. Where basically they were trying to solve, among other problems, that if you have something that's trying to generate, let's say, language, right? Let's say translate like from one human language to another. It's trying to translate French to English. Okay, that there is a limited amount of ability of previous methods to look back at previous words in a sentence when you're doing a translation. It's sort of the translation methods were largely looking at the previous word and the current word and saying, how should I translate this word? Now, that could be a problem, though, when you're trying to translate a language where you switch the order of words. So like in the European languages, the adjective tends to come after the noun, unlike in English, where we have this cool way of putting cool before the word way. So that was a problem for things like translations. Now, among one of the many things that transformers fixed is they had this thing called the attention layer, particularly something called self-attention, where it's able to very selectively pay attention to certain words in a sentence that came before it, sentences before, maybe in paragraphs before. I think the limit currently with new transformers with ChatGPT is something like a few thousand words, maybe. So I think it's something like the limit right now. That was a big innovation, which means that it can keep track of a plot line in a short, like in a little tiny short story it's writing, right? In addition to keeping track of maybe what the adjective was earlier in the sentence. And that's super useful for chatbots, because if I ask you an example I saw of something a chatbot would need to discern would be if I type into the chatbot, excuse me, server, can I have the check? Versus the server just crashed. What does server mean? Well, we know that based on the context that I meant both either the waiter or the waitress, or I meant the computer server. And that's dependent upon the context of the rest of the sentence. So the idea of being able to pay attention selectively to different words that had happened elsewhere is critical to having a good response. And so that and a few other changes, such as the positional data of words, etc., is what allows transformers to be such effective chatbots. And what they'll do is that they will have a transformer like that. They have an input architecture and an output architecture. One is where you send in your prompt, and then it uses attention and all this other stuff in order to figure out what you're trying to say, at least some approximation thereof. And then it generates a response. And the way it generates is that it's using the same kind of similar kind of structure, but it is picking out words one at a time, boom, 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 and it's trying to predict of all the words at my disposal. They call them tokens in this language. Which of these words, tokens, is most likely to give me a good response? And so it'll choose the one with the highest probability, roughly, and say, that's my next word, until eventually it comes up with the token called end. And then it ends the sentence, right? It ends the response. And that's the generative part. It generates this response. And it's trained. And so that's number one. That's the architecture of how it's put together. All right. So if you want to sound cool, about when you're talking about transformers, you talk about self-attention. Like, oh, it's self-attention. Cool stuff. And in terms of how it's trained on gobs of internet data, of text from the internet. I think we're talking about terabytes, I believe ChatGPT was trained on. And it has a ton of different examples of people talking and on the internet. And shocker that that's the case. And so, and if you have a neural network that is scalable, meaning that we can computationally train it using our best computational training techniques. And you have gobs of data. That tends to be a pretty good recipe for amazing results.
Mm-hmm.
And that gets you a lot of the way there. So a lot of what's done is training this network off of existing human data. There are additional things after that. You also want to, is a layer of reinforcement learning where you're giving it a reward, where you have some humans who are actually trying to, interface with the chatbot and tell them more or less were these good or bad results. That way you can sort of craft the language model so it gives you the types of responses that you want. And that is no easy feat, but they found a way to do that.
Mm-hmm.
And the result is the ChatGPT you see today. That's roughly how it works.
Yeah, so there's a couple of things that you mentioned there. So one of them was this idea that, the limit of how far back it can look is, maybe 1,000 words or so. So that's probably great for, compiling an email or, a tweet or some sort of short response. But if you were to actually write, a Stephen King length novel, then it's probably going to fall apart in that case. You're going to lose the thread of the plot, right?
Sure.
But you also mentioned this, training data, this using the internet data, the gobs of data. And I've seen, a number of, articles and people expressing concern essentially over using internet data and, there's privacy concerns. But I think one of the big concerns that comes up, especially really around any kind of model training, is limitations in terms of bias or ethical considerations. So what are some of your thoughts in terms of, relying essentially on internet data and the potential problems that can lead to a bias? I mean, if we search Google and I get a result, even if the response, the article is biased, I at least know who the person was. Whereas in ChatGPT, I'm basically getting essentially some response that I don't really know who produced it.
Yeah, I mean, so I'm sure there are people who are thinking of really clever solutions to this kinds of problems. I mean, one that might come to mind is that there is the element of sort of retraining the network based on user feedback, the reinforcement learning part, and you could have some principled. One thing you could try to do is have some principled bias detector that you could try to train it on. And I won't say that would be easy. At least that might be sort of a Band-Aid, a patch, if you will, to take what is being spit out and then trying to make sure that it's sort of rebalanced to reflect what you would determine as a bias detection. Now, that's a bit of a patch as far as I'm concerned. Now, the other part, the pessimist in me, let's just say, or maybe the constructive critic in me, how about that? We'll go with that today, is that it is because it's being trained on existing human interactions, almost exclusively in terms of how it's generating its results. That does limit its ability to reason. It's sort of reasoning by probability. It has seen these words strung together, and it's able to generate some kind of structure around them, which is very impressive. But there is no reference to some external truth or reality.
Mm-hmm.
That's why you can get it to say on occasion that 1 + 1 = 3, or it's not that simple. It's pretty good at detecting that 1 + 1 doesn't equal 3. But if I could ask it in a convoluted way, I can sort of prompt it to give me an answer that tells me in effect that 1 + 1 = 3. Mm-hmm. That it doesn't have some underlying principles to say this is what is true of a true response, and it lacks a model of. It's a great model of language, it seems, but not a great model of reality, which is what people seem to want to use it for. I think that if we're this is why when people talk about using it as a Google replacement, I was kind of surprised. I always thought it would be the kind of thing, a chatbot. This is my bias. I'm curious what your response was from back in the Alice days, Sean, when people were talking about this. But I always thought this would be an interface to deliver sort of preset information. Imagine you had a ChatGPT that was the equivalent of the phone operator when you have to call your internet service provider or something like that to like, handle your bill, right? So that way you're talking to a machine, but it's a more conversational machine. But the information it's grabbing from is from like a very clear, like, authoritative source. Like, this is the company policy. This is the policy on, doing these kind of refunds. This is the policy for repairs. Instead, it's almost like people are trying to use it as a one true knowledge of everything. And I find that to be it's not ready for that. When I tell people I'm sure it's close. If I'm just going to give my personal opinion on there, I think people mistake it for being wise, in that it's so good at imitating the speech patterns of people, and it's excellent at that. That people will say, half jokingly, saying, "I don't know the answer to this question. I'll ask ChatGPT. I'm sure it knows." But in fact, it knows how to give you an answer that sounds like an answer that you want to hear. But in terms of the bias question and all these ethical concerns, it doesn't have an ethical set of principles. And in a way, I have to congratulate the ChatGPT team. And in my opinion, they did a reasonably good job of patching it up so it doesn't do too many horrible things. Like, it's like I would hear rumors of what it was like when they were training it, like when the chat bots would like act like psychologists and give, let's just say, less than optimal mental health advice when prompted. And they've somehow managed, I think, I haven't seen too many horror stories about that off of ChatGPT, but those are patches. It's still constructing language from examples. And in my opinion, if you want to get to the point where you want to trust this thing as some big source of information, it's got to have some set of principles beyond monkey see, monkey do.
Yeah, and I think one of the challenges that some of the older systems that have like tried to do things around like chatbots and is they are learning. Their training's ongoing. So the downside of that is someone who's malicious can basically go and train it to do something like ridiculous. And that's been kind of the downfall of some of the past techniques that have been used. So you brought up this idea of like, it was surprising to you that people were talking about this as like a threat to Google because of these problems with the system that you're talking about. There's lack of source attribution. It sometimes just makes stuff up that kind of looks right, but is not really right, which in some ways is even worse. But I think some of the practical applications that I've seen and actually have used even for myself is more around like being the starting point for generating something, like generating an email or maybe generating a summary. Is more like vertical specific or application specific uses of it rather than, hey, I want to know the answer to this question. And I've actually seen, for example, I looked up, I think you really start to see the cracks in ChatGPT when you start to ask it more sort of obscure questions. So if you ask it kind of general knowledge stuff, it's probably pretty good. But when you start to go, into things that are a little more specific, a little more niche, you get some pretty crazy answers. I've experienced that a little bit myself. But what are some of your thoughts, I guess, on some of the practical uses of the ChatGPT system today?
Hey, that's a great question. I'm glad you're going here because I don't want to sound too much of a Johnny Raincloud, Debbie Downer, or something like that. I do see potential applications. I mean, like I'm in the field of trying to make computers make smart decisions. So I want to be an optimist here, and I think that in terms of the uses, like I think that there's a lot of use potentially for the coding generation, for instance. This is just as a person who does a fair bit of coding. Thankfully, on a good day, my students do the coding, but sometimes I have to do it too. And where a lot of it's just busy work, a lot of it's just the same thing you've done 50 times, and ChatGPT has probably thousands of examples of it. Just generate me the skeleton of this code, or just this one little block that does this one thing. And I've already seen people. Obviously this has been incorporated into GitHub. And that service is available, and I haven't made strong use of it, but I could see the potential for something like that. And that's just in coding. And I think that what will bear out is how useful people find it in practice. A lot of times, I fall victim to this. I just bought a new widget, and I swear I'm going to use this all the time. And then, it's shiny and new. I love it. It's going to make everything nicer for me. And over time, I realized not as useful as I thought. So we'll see how it handles that part of the cycle. I hear one of the lead Python developers. I think he claims to use it all the time. Which if they keep using it, I'm open to that kind of thing. And that's coding. But you could do the same thing for emails, right? And so let me sort of broad stroke it. Things that are relatively low stakes with a lot of busy work, where you have a lot of prior examples, are just great for something like a generative model for this. That's awesome, right? It's kind of like I when you go to get like an automatic email response, you can just say, "Hey, thanks." "Oh yeah, that's great, thanks." Right? What if you had a smarter response available for you, where you click up from a few of those as like a suggested autocomplete for an email? That'd be awesome. Mm-hmm. I can totally see something like that becoming super great and just being a part of Microsoft's productivity software, right? Where it's mostly when people try to use these systems where the cost of failure becomes increasingly high. And that's where, especially I'm in robotics, we want to put these algorithms in meat space where we live, and we don't want them falling on us or accidentally puncturing us, kind of thing. That's where we worry about it. I'm sure we'll get to that, mm-hmm. But I think I've heard people use it for things that are, again, low stakes. Cost of failure is low, as sort of a jumping off point for fiction. It's almost like it's like a prompt for you if you're like an improv comic or you just want to write on a thing. It's like a random source of interesting inspiration to fill in the gaps. Mm-hmm. Things where you can, let's just say, sort of BS your way through, right? That's really good for that. So I'd say those are the good applications. I do fear there are some bad applications, but I don't want to be too negative today. But I'm sure that things like spreading misinformation, I think, could be of huge use for a chatbot. It's already supposed to be not obeying sort of underlying facts, so you could use it to do that, right? Or cheat on exams, but. Something that concerns me. Yeah. But those are the positive applications. Just like eliminating some of the drudgery, the uncreative overhead of the things we have to do every day.
Yeah, one of the things I've been thinking about is if the ChatGPT or similar systems that come along are using essentially internet in things on Reddit, for example, like dialogue of responses in websites and so forth to train on. But then we imagine a world, let's say fast forward 10 years, where Microsoft and Google and all these different applications essentially have some sort of ChatGPT like system baked into them so that we can just auto respond to those things. But then essentially the training ground for these systems become the data that was generated by the system. We enter a world where, essentially only a very limited amount of information is actually uniquely created by a person, and most of it's somehow assisted or completely generated by the model, and then you're kind of running out of stuff to actually train it with that's actually human generated.
Yeah. I mean, so these models, in my opinion, everyone struggles for analogies for ChatGPT and these large language models. I think it's a skilled interpolator. Right, mm-hmm. of human knowledge we've already generated, less so an extrapolator of coming up with some newfound knowledge or newfound technique, or it's taking the data that it has and stitching things together that it already has into something, into a response. So yes, theoretically, if this is a closed system of information, we would have a very stale world of information if it was all generated by ChatGPTs. I have less of a pessimistic view on that of that kind of outcome, because what I think it would do is potentially free us up to actually write the things we care about or the things we are creative about. I loathe having to respond to just a pile of emails. What I wouldn't give just to say, okay, I get the gist of this. Thank you. All right. Yes, yes, yes. But the stuff I'm excited about, I could focus on that. And so I try to think of an analogy to things in the past, things that we take for granted, like now. Like I'm sure there are people who are mad at the typewriter. Because I'm sure it took away some of the artistry of writing in longhand. You know, and sure, I'm sure it did. But you know, there are still times where I write in longhand these days, and it's because it's something I really care about. I'm writing a thank you note to someone who I think it is, or I will maybe write my own font. You know, when it's something I really want it to be special and mine. It's just the things that I don't care what the font is or what the script looks like that the computer or the typewriter has replaced. So I think I'm more come to an argument of focus. Where do we, let's call it attention, just to bring it back to our previous discussion. What do we pay attention to with our limited executive function of our brains? And so I'm optimistic that if we can get it to work reliably for low stake situations, that's what we could do with such a technology.
Yeah, I think that's a great point. I mean, I think with any sort of new innovation in technology, there's always a lot of initial reaction of, oh, well, this is going to make this obsolete, or this is a threat to, jobs. And a lot of times it's really about making people more efficient so that they can actually focus on things that are, more complex tasks. I mean, even when it comes to programming, a lot of programming today, you're offloading some responsibilities of coding to APIs or libraries that, take care of things so that you can focus on building something new that's going to be interesting and innovative and so forth. So you don't have to go and build like an auth system. You don't have to build a database from scratch and so on. If I don't have to respond to all my emails, that would be fantastic. Free me up to do more podcasting. So you touched on this a little bit earlier, or a couple times, about essentially people using this for cheating. So both my sisters are teachers, and I know there's been a lot of concern over students essentially being able to use this to write a book report or, whatever it is. So is that a legitimate concern? And then maybe, what are, your university thinking about how to prevent stuff like that?
So it is certainly the talk of the educators in my life as well. I mean, I again, I'm less apocalyptic about it than I think I've heard some other folks. I mean, we've had to fight the cheating wars in so many different ways over the decades. I mean, when I was in school, Cliff Notes were a thing that you could go to, to give you summaries of novels. That way you wouldn't have to actually read the Scarlet Letter. I literally fell asleep with the book on my face, the Scarlet Letter. Maybe I'll enjoy it more as an adult. I don't know. But so people found a way to write more in-depth questions, right? We had to adapt our methods so that way you couldn't just answer it with Cliff Notes, right? And the same thing's going to happen with ChatGPT. I mean, it is going to force some kind of innovation and adaptation amongst educators. Things that would have just required people like by coding a pendulum assignment that I would give to my lab students. I know that if I give that to them, they could have just ChatGPT'd it. In the past, so we'll have to adopt some techniques in order to actually test the students' knowledge of what you actually want them to learn. There are so I mean, obviously in-class evaluations are very valuable in that way. I mean, that's the simple solution, but it isn't always simple to implement at scale for the size of classes. Some assignments just take a while. You might have to ask more obscure, for take-home assignments, more obscure questions. Be very specific in what you're asking for. I actually found a weird trick. Am I clickbait now? I don't know. One weird trick. Try this out for yourself if you're playing with ChatGPT at home. I tried to give it a writing prompt, but it gave it an exact word limit. Like I said, like write something in like 27 words, a response, and it just flubbed phenomenally. Maybe it wouldn't do it every time. Just try this at home. I could be wrong. I'm curious if it works for you, but it makes sense when you give ChatGPT a weird constraint, that it would have a difficult time. And I think that, and this is actually kind of related back to my research a little bit. When I'm doing robot control, I'm trying to say, hey, algorithm, come up with a robot controller that's going to make my robot, walk to the end of the room and then do like a John Travolta, disco pose, right? It's unless you're very careful how you set up your algorithm, it can have a hard time figuring it out, because there's lots of things that can go wrong along the way that would prevent you from hitting the disco pose. And unless ChatGPT is really smart about counting its words along the way, which I don't think it explicitly does that. It has to kind of learn to implicitly do that. It tends to lose track of that kind of prompt, in my opinion. I think I tried it like maybe to ask it to summarize the Scarlet Letter in like exactly 10 words. I gave it like 10 tries and it got like down to 9 somehow. I don't know how it did it, but it got close. So anyway, so adding some weird constraints to the problem sometimes can help. I mean, and I think that what it comes down to, though, I mean, what you really would love to ask yourself is, what you really want the students to know, and how do you test that thing? Because no longer can you just rely on the fact that words are on a page in the form of a sentence is sufficient evidence that this was written. So how do you test for insight? I've done exams where I've had people generate code at home, and then in class during a Zoom session, I told them to change their code to do something else, like something related. And that was just a test to make sure that this was pre-ChatGPT, but this was just a test to make sure that they didn't copy it from another student or something, and that they had to know what their code did and explain something about their code. So maybe there's ways to test the core of what you're asking beyond what you did. But I don't know, but I think we're still all figuring this out. It's I imagine there's a lot of people right now having similar kinds of discussions in departments across the globe.
Yeah. I mean, I think that even computer science departments had to adapt a lot when the internet became, and suddenly source code was all over the internet. Like, you couldn't just ask somebody like implement a merge sort, because I can go and look up merge sort in any language that I want and copy and paste it from the internet, and I'm done with my homework assignment in 2 minutes. But you can take a question like that and, like you're suggesting, adapt it, make it a little bit more specific than just a like routine algorithm or something like that. And I'm sure similar techniques work for written, book reports and so forth.
Yeah, and we'll go. Yeah, and just to sort of put another little twist on that question. I mean, people have been able to cheat for years by just paying someone to cheat on exam for them. I mean, that gets a little bit trickier on the technical stuff. But there were services people would pay for to write their thesis. I remember I read a wonderful article, I think in the Chronicles of Higher Education, which was sort of the private confessions of a professional cheat, and they would get paid to write a thesis, so long as there was no math. I remember was the constraint that particular person had. And I mean, that was always available, but what changes here is the availability. It's like you don't have to pay somebody. So it's more freely available. So I'm confident that we'll find reasonable countermeasures to, even though it won't weed out everything, at least it would discourage and make it more tricky to cheat. So exactly what that form that will take, we will see.
Yeah. So I want to start to talk a little bit about, your area of expertise, robotics. We touched on it a little bit, but do you see an overlap between essentially the science behind technology like ChatGPT and robotics?
Definitely. And it is an interesting analogy. And one thing I got to say is that the general AI / machine learning field has, kudos to you all. Kudos to you, friends. You're making such wonderful strides. Every other field, I'm sure, is at least partly jealous. Not speaking for myself, of course, but like robotics is coming a long way. But I will say there are a lot of people who thought that, we have these algorithms, doing crazy things, like they're generating AI Seinfeld on Twitch, which and they, like it's a kind of a goofy TV show, but it is a TV show on Twitch. Endless Seinfeld that was being auto generated, and yet we can't have a robot make us a sandwich. Like it's robotics is progressing, but it's still far behind. That said, some of the parallels are interesting when we talk about ChatGPT. That, in my opinion, one of the big limitations is it doesn't have a strong grasp of reality, or if any grasp of reality at all. It's not trained on any physics of the world it's in, or any actual experience of the world it's in, just in the language that describes what people have done in the past. And it's a model, but it's imperfect. It lacks a model of the reality it's actually living in. This is something that I think, a really hot topic in robotics right now, because there are, I would say, this is my take on robotics as a researcher. Sort of two camps in terms of robot control. How do you control a robot? One is model free, and the other one is model based. And basically, does your controller have written in it somewhere the physics of your robot and the environment that it's in? Okay. And if you do a reinforcement learning method, you're probably model free. You've trained your robot maybe in a simulation with a lot of experience. You try lots of trial and error, and use a deep neural network to construct a controller to come up with a better result. And those folks, just in the last handful of years, I would say the last 3 years, have made enormous strides. I mean, I work in legged robotics, and some colleagues at my alma mater, which was Oregon State, in the lab where I graduated from, after the deep learning boom, they applied deep learning to a legged robot to break the land speed record for a bipedal robot. They did the world's fastest robot 100-meter dash, and they did it using model-free reinforcement learning. They had a computer simulation. They gave it a lot of opportunities to try to come up with new ways to run, and they put it on the physical robot, and it ran a 100-meter dash. It's incredible. It's incredible, right? And so the control policy, as we called it, sort of the smarts of control, are all embedded in a trained neural network. Really cool stuff. Now it is, though, limited largely to what it's been trained on. I mean, it does a good job, but it's still limited to the situations that it's been trained on to try. So the model-based folks, which I find myself a little bit more in that camp, is yes, it's great to have a beautiful neural network that's trained to handle all these situations. But what if you're in a new situation? What if things have changed? What if your robot suddenly, one of its motors is kind of burnt out? You only have half the torque in that motor. Or you're suddenly stepping on a new material. Let's say you're trudging through sand all of a sudden, and you've never seen sand before. It would be sure great if you had some ability to model the physics of that system. And as a result, it'd have the ability to reason on board the robot how to change its behavior as a result. So that is theoretically very nice. The challenge there is that it's actually a lot of computation on board to think and reason all the time with a robot.
Right.
The method that I think is most applicable, if people want a buzzword in robotics, is called model predictive control, or MPC, which is sort of the thought of, hey, if you have a mathematical understanding of the physics of this robot, you can be clever about your computations and figure out a way to predict how your robot's going to behave in an environment and make a smart decision based on that. And so those are sort of, I'd say, the two camps in terms of robot control out there. And where this sort of applies in terms of analogy is like, man, ChatGPT taking a bunch of data and using a neural network to stitch it together into an interesting solution. And man, it can do some amazing things, right? But it doesn't have a fundamental understanding of the reality that it's in. So that can lead to situations where it makes silly mistakes, right? And it's partly the reason why I feel in the future I would love to see these methods have a better model of the world we live, not unlike a robot.
Yeah, so is there also hybrid systems in robotics where you're using essentially the model to understand, some of the physics so it can adapt on the fly, but also using like reinforcement learning to build, the initial version of essentially the learning algorithm.
Yeah, sure. Yeah. And that's natural. Whenever you have people in almost any field of engineering, like, man, if only I could put chocolate and peanut butter together. There's someone trying to put chocolate and peanut butter together, right? So so there are model-based reinforcement learning techniques that people are working with. I'd say it's still, I think, in its infancy. That one of the I should say not its infancy. It's still pretty new, but it can be pretty exciting. The trick is how you get those things to play together, because you have, on one hand, you have this this neural network based approach where you're training neural networks. And one of the things about neural nets is that you want that every single function that you have at your disposal, you want a nice derivative of it. Not to bring too much calculus into this, right? But you want to have a nice smooth curve for that mathematical function. It's defined by a bunch of like the lines or surfaces that are all smooth. And if you know the slope of that line smoothness is that's your derivative, right? Mm-hmm. For those who maybe missed who hadn't lived calculus in a while. And so now, however, if on the other hand, you're doing this model-based control, which is doing all this advanced reasoning on the fly, how do you take a derivative of that reasoning? And that's been the challenge. How do you come up with a smooth curve that describes how that reasoning responds to whatever situation you're in? And there are people working on that an exact problem, that how do you take this derivative of the result of some planning algorithm? And so there are people working in that space. And I think that's really interesting. So that would be an interesting chocolate and peanut butter solution that I'd be really on board with, to really both leverage the sort of uncanny way that neural networks can just stitch together a bunch of information and come up with an answer, with the principle-based reasoning that you get from having a model understanding of your reality.
Mm-hmm. Yeah, and imagine, like, if you think about, like, humans is probably some combination, like a baby that's just born understands when they touch something hot that it hurts. You have these sensors basically that is your model of reality, but then you're also learning all the time so that you can learn new skills and adapt as well. So I guess that's kind of like the goal. That'd be the perfect system perhaps for robotics.
Mm-hmm. Yeah, I mean, it's for sure. I mean, and I swear this is a coincidence you brought that up. I swear I didn't put it up to you. But that's the exact analogy I give when I talk about my own research, mm-hmm. right? Some of the methods we're working with, it's trying to blend a bit of learning with this model-based sort of reasoning and planning on the fly, where one of the things about the deep learning methods is that you need a ton of data. ChatGPT is trained on, like terabytes of text. That's a lot of text. It's it takes a while to train the model. I actually don't know how long it took to train ChatGPT, but I imagine more than the time it takes to go out for coffee, I would assume, right? But however, the baby touches the hot stove, it doesn't need to train this neural network for days to realize maybe not do that again. And that whatever I do, I'm not going to touch that stove, even if I have to do other things. And so that's the kind of work that I'm doing right now, is where we do what we call low shot learning, meaning very few examples, mm-hmm. of trying to learn the thing that caused you to fail or have a bad experience, and build a very simple machine learning model based upon those few experiences, and then plug that into your model-based reasoning, which allows you to think on the fly as to how to respond to other new scenarios. So you touch the hot stove, but you can still have to do stuff. So, like whatever else you're doing in your kitchen, you're mixing the spoon around, just don't touch that hot stove again. And so, so I feel like, so that sort of touches on one of the other things that makes ChatGPT so great, is the huge amount of data. And if you need to respond to very little data, you might want to use a different kind of technique.
Yeah. I mean, that's kind of what I was mentioning earlier, where I think you start to see some of the problems with ChatGPT when you ask these more niche questions, because it probably has limited amount of data actually, be inputs to the model. So back to your research with some of this like limited example training, can you talk a little bit about like how does that actually work in practice?
So sometimes it's incredibly simple. I mean, what's the simplest machine learning algorithm I can think of is a linear fit on Excel.
Mhm.
In my opinion, that's machine learning. And so if you have like 3 data points, what can you do with that information? And you maybe draw a line through it, maybe throw some bell curves on it, right? And so when you're incredibly limited, you have to deal with some really low order methods. Like it can be that simple. And then there's sort of a sliding scale that you can use depending on how much data you have. I mean, you have almost no data, you draw a line. Just like that's machine learning for you. If you have a little more data and you're trying to get a curve, I mean, there are things called like a Gaussian process regressions, GPRs and GPs. And those are nice for a certain scale of data.
Mm-hmm.
Now, those don't scale up to the kinds of stuff you get for a neural net. You might have to go up to a neural net when you have thousands or tens of thousands of data points, and if you get more than that, you might have to go to a deep neural net. At that point, that might be useful. So there isn't a one-size-fits-all problem for learning in the context of robotics or anything else. And I think that's why there's this beautiful zoo of different machine learning architectures, neural network architectures. I mean, I think that part of me, maybe in another life, would love to experience the world of being a deep learning architect, where I know, I'll throw in an autoencoder in here. It's like I'm cooking.
Mm-hmm.
It's like I'm like a recipe. It's like, you know what? I could use a little dash of salt, dash of pepper. Oh, here's my ReLU layer. It's like so I think that part of the artistry of that is having an idea of what's good for what, and so that depends upon how much data you need and what it's used for.
Yeah, and I imagine the computational complexity is a factor as well. Like if you're dealing with robotics or autonomous vehicles or something like that, where reaction time might be really important, you can't be doing something that's like going to cause too many thinking cycles, essentially, when reaction time is so important, because it could mean both like destruction of the robot, but also potential harm to a person.
I feel like I've unintentionally steered you into my work. I'm buried in right now as a faculty member. I have my laboratory is pressed up against a conference deadline, and we love to get all our papers out. And all of our papers this term are for this push. I realize are all on this exact problem: is how fast can you get an answer? And so, like we're trying to get every aspect of the computation from the data collection to the learning of a model from that data to the using of that learned model in a control calculation, all down to a millisecond or two. So, I mean, that's sort of the sort of arbitrary standard in robotics for how fast you would want something and be quote unquote real time. A lot of the time is at a kilohertz, so 1,000 hertz, so a millisecond thereabouts. That's where we try to aim for. Which is it's funny because we're dealing with like dynamic robots. We're talking about robots that if you don't make the right decision, it's going to fall down in a fraction of a second. So you better know where you're going to want to put your foot if you just got pushed, or you're about to walk into grandpa. You want to reverse course, or a drone is going to flop on its face if you don't get the right calculation. So a lot of the methods that we use nowadays in robotics weren't developed by robotics folks. They were developed in applications where you had a little bit more time to make decisions, such as chemical engineering plants. That's actually where a lot of our algorithms got developed, because they could take minutes to an hour to maybe make a decision as to how to handle the mixing of this particular chemical into the other chemical. So they were some of the our forefathers or foremothers of these algorithms were our chemistry friends. And so because so much of the choice of algorithm for us is driven by how long it takes to compute.
Yeah, and I think you're kind of working in like two areas that I think people who are not well versed in those areas of like AI, robotics, there is this often like negative reaction to those things. And we talked a little bit about this earlier, threat to jobs. I think in robotics, it's not only threat to jobs, but, potentially physical threat to people. So I guess what are your thoughts on the potential impact of robotics to people's jobs or even someone's personal safety? Because I think whenever we see those like crazy robotics videos of some robot doing a backflip or something like that, everyone's like, oh my god, crazy! It's time to abandon ship. The robots are taking over, but it feels like, just based on our conversation, and I've heard you speak before, we're quite a ways away from something like that ever actually happening.
Sure, we are. And I'll answer your question, I guess, on the small scale first, then sort of zoom out to the larger scale. So let's take that example you just talked about. Like, we hear about the people, you're probably referring to the Boston Dynamics videos of the robots, which are tremendous. They do a wonderful job at Boston Dynamics of making these, particularly for their humanoid Atlas. That's the one that's doing all the backflips and dancing to music. They do wonderful proof of concepts, and they're selling their spot robots right now, which are their quadrupeds. They're selling them for companies for actual use in people use them in facilities to inspect their power plants, that kind of thing. It's very easy and understandable for people to watch those videos and think, wow, robots, they are here, and they're going to do anything that I can. One, you got to remember, this is a demo. And I'm sure that you work in a tech startup business. I'm sure you all know what it's like to put together a demo and maybe to see a demo for another company and say, okay, how often does that really work? And it's not dissimilar with Boston Dynamics. They're actually very upfront. I respect the company, and that they will actually show you how often the robot doesn't work, and which at least give you some examples to show we got more space to go. Additionally, you got to be mindful of that robots have their limitations, and a big one, especially for legged robots, I can speak with a little bit more authority on this as a legged roboticist, is like things like power consumption. You don't see these robots operating for very long a lot of the time. There's a reason why the videos are short, and it's not just because of YouTube engagement. It's and they will tell you. I need to find the article, but they talked about the battery limitations on their humanoid Atlas doing a dance for, I think, the "Do You Love Me" song from whichever decade that was from, and they had to expand the battery capacity to make it through the whole song. I believe is the story, because it uses so much power. So there are often hidden limitations to the robots that you see in your YouTube videos that prevents them from taking over your job in the near term. Mm-hmm. Okay, but that's the sort of the small scale. But let's write that up to large scale. Okay, let's assume that for industry X, for a particular industry, there seems to be a robot that does the thing, and let's say they worked out a lot of the technical details where it's reliable and it's actually fieldable with the practical limitations that it has. And I'm not an economist. I should preface this, but we have somehow managed with automation over the years to find new jobs for people. Now, that does not to minimize that finding that if you, for some reason, you happen to be in the direct path of the exact thing being automated, that's not an easy thing to have to change a job. So this is like a worst case scenario. But we always find jobs in related sectors that people are that we need people to do. Mm-hmm. How many people were farmers at the turn of the 20th century? As opposed to now, vast minority of people are farmers these days, because a lot of farming has been automated. Now you have a job, Sean, that I'm sure was not in the twinkle of the eyes of the early 1900s folks. New jobs of different types get made. That's just more of a general response. Mm-hmm. And I will say another angle of it is that we're actually very bad at predicting whose jobs will be replaced by automation. A lot of times people think autonomous cars, they're right around the corner. Yeah. Drivers are going to be truck drivers are going to be out of the business. We're still waiting on that. And things like that. So it's actually very hard to predict what jobs are going to be replaced. So I think imminent panic for the most part, I think is pretty unfounded. until we really mature the technology and see what it's really good for. Even then, the impact on the economy is hard to predict.
Yeah, I mean, there's so many things that, going back to the, moon landing. I think if you asked anybody in 1969, where would we be today? We'd all be exploring deep space, have multiple, human habitations on other planets. And we're not really that much further ahead than we were in 1969 during a space exploration. And I think also your point about demoware is a really good one. I remember when I went to Google I/O in 2018, Google had demoed, I forget the name, the exact thing, but it's basically the Google Assistant goes and calls up, like a barber shop and schedules a haircut appointment. And everyone was blown away by the realism of the voice and the pauses that were happening. I'm still, we're all still waiting for that to actually be a release product. It's great in a demo, but I think in terms of actually being a releasable product, to my knowledge, they didn't even test it with real people at any point. So,
yeah, it's a tough world. I mean, to get something to function in our reality is hard. I mean, you're much more in the business world than I am. I can happily toil away in my laboratory and never have to sell a product in my life. But if you cross that gulf of proof of concept to implementation to market, is the valley of death? Is that the phrase for? What is the valley? I think there's a phrase for it or something like that. It's just that where so many things can go wrong, and it could be as simple as like people just don't like it for whatever reason. I mean, I remember when Google Glass was going to be the next big thing, and I don't know why that failed, other than people didn't want a robot on their face. I don't know.
It looked pretty dorky too.
It looked really dorky. Fashion counts for things, and so I think that what that means is that when you see a demo of something, and I would consider ChatGPT demo-esque. I mean, people are using it, but like it's I see it as proof of concept for me, for the most part. Like I think when something is at this sort of stage, it's not the time to think that to apply for different jobs, in my opinion, because you don't know how it's going to be adopted. And that could be premature. I mean, and even some of the things. This is another sort of side point. Like the things that we're trying to train ChatGPT to do. I mean, people talk about how, if you want to be, have great job security, become a programmer or a coder or whatever you want to call that person, right? I mean, I would not have guessed 5 years ago that the large language model that was going to, be writing Shakespeare fan fiction is also writing like pretty, interesting, is also writing like my optimization algorithms. I would not have expected that. So we can't. And I think it's kind of surprising, and maybe that's also a bias of the people who make these things are also coders, so they're very good at maybe making them do the thing that they're already very good at doing. I don't know. It's very hard to predict.
Yeah. Yeah. So, bringing this back a little bit to robotics and ChatGPT, how do you see the field of robotics kind of evolving in the next, 5 to 10 years? And what role do you see things like ChatGPT or, similar types of models playing in that evolution?
Well, already in robotics, there are people who are using the equivalent of large language models to help build instructions for robots. I mean, I happen to work on just as a disclosure, my laboratory is funded by the Toyota Research Institute. It's a research institute funded by the Toyota automaker company, and one of the things that they are interested in is robots in the home. They're motivated by, among other things, being a Japanese-founded company, is the aging population in Japan, not having caretakers as the population gets older. So they think that, I think very wisely, that at some point there'll need to be a market for home robots to do normal household tasks. But the process of trying to get a robot to do a task could be formulated in a way kind of like a ChatGPT, where it's coming up with a bunch of tokens, which were words, but maybe are now actions. Like, I want to make a sandwich. So maybe there's the open the open the door, the cupboard door token. There's the pick out the bread token, and maybe structuring them together in a way that has been trained in a way that makes sense. I believe a colleague of mine actually, I think he published some work. It's definitely been publicized for sure in Quanta on how they would use these kinds of models to synthesize a set of actions for robots. Now, but I think that one thing people in robotics also do acknowledge is the problem of safety, and that again the cost of making a mistake with a physical machine around physical people is high.
Mm-hmm.
I mean, look at self-driving cars. I mean, classic examples. So in terms of these large language models, they may be good for generating a sequence of tasks to do that would be difficult to find via other computational means. But you also need that level of safety, right? So, so the people are certainly working on ways to have the, let's just say the flair, if you will, of a ChatGPT, but with the safety where you can count on it. So a lot of so there's a lot more blending between the, let's say the ML/AI, the people who are doing the neural network type architectures with what we call the more sort of traditional controls types. Controls folks tend to be mathy people. Not that people in AI aren't, to be clear, but they're some of the mathiest people I know in my field are the controls people. My postdoc advisor, he bragged that he managed to get his PhD in electrical engineering by only taking math courses and doing controls, and that was like point of pride for him. And with mathematics, you can often try to get some certifications of safety. So people, and there are all kinds of things in the controls literature for how you would guarantee, in theory, guarantee that a robot with this particular controller, if the controller continues to operate, will never, fail, or at least will never stop, or guarantee you complete the task, or at least never bump into a unsafe region. Mm-hmm. So where this goes is in the future of robotics is finding ways to use the flair of neural networks to do cool, crazy things, but meshed with that layer of safety and certification that we want to have in a real product around real people.
Yeah, so I think that's a great place to start to wrap up. But as we start to say our goodbyes here, anything else you would like the audience to know? Where should they go if they want to learn more about some of your research, for example?
Well, so you can, if you want to find me on social media platforms, on the Twitters or mostly Twitter, also Instagram, you can find me at Hubicki, which is Chubicki. I think Chewbacca's younger brother is what I always say. And you can find my work at the optimalroboticslab.com. So optimalroboticslab.com. That's where you can find my published work for my lab, which is a couple years strong now. So we're continuing to grow and publish, hopefully, things your audience will find interesting. And in general, just hopefully you could see your audience around the conferences. That'd be fun. If you happen to run into me, stop me, say hello.
Awesome. Well, Christian, thanks so much for coming on. I really enjoyed digging into ChatGPT and, talking robotics. Hopefully, we'll have another opportunity to have you on back down the road, or maybe I'll run into you at one of these conferences. But thanks again and cheers.
Thank you. Either way, it will be a pleasure. Thank you so much for having me, Sean, and you have a wonderful day.
You too.